Okay, homework time. Homework time. Boom, homework time. Boom. So we did this at the very end of class. So they give you an example that you can look at. And then number 1 we already did in class. So I won't do number 1 because that seems silly. So what you're doing is you're finding the point of intersection for the two equations. So remember, the point of intersection is where the equations are equal to each other. The point of intersection is where the two equations are equal to each other. The intersection is where the two functions are equal to each other. Where the two functions, f of x and g of x, are equal to each other, that's the intersection. Okay, so your first step is I'm going to put my two equations equal to each other because I'm trying to find the point of intersection. So I have 1/2 x plus 2 equals, what's my other one? 2x minus 7. If you want, you can multiply everything by 2, and that gets rid of your fraction. I'm not going to do that, but you can. All right. So then you have to get all of your x's on one side of the equation and all of your regular numbers on the other side. So I'm going to move my 1/2. So I have 1/2 x, I'm going to subtract 1/2 x, and then I'm going to go to my other side of the equation and also subtract 1/2 x. We'll go down. So 1/2 x minus 1/2 x is 0. So the only thing left on this side is my 2. So I'll rewrite my 2 equals. Then 2 minus 1/2 is 1.5 x, or you can write 1.5. You can write it as a fraction if you want. And then rewrite your minus 7. Don't forget to rewrite. Okay, now I want to get 1.5x alone on this side. This is in the wrong spot. So we're gonna add 7. So if I add 7 on this side, I also have to add 7 on this side. Plus 7. Oh, plus 7. And then come back. Okay. 2 plus 7 is 9 equals. I didn't do anything to my 1.5 x, so I just rewrite it. Didn't do anything to him. And then negative 7 plus 7 is just 0. So that's gone. So this is what you have left. All right, so this means 1.5 times x times some number equals 9. To figure out what that some number is, you're going to divide both sides by the number in front of the x, which is 1.5. So I'm dividing both sides by 1.5. 9 divided by 1.5. 9 divided by 1.5 is 6. 1.5 divided by 1.5 is 1, so that gives you 1x, which is just x. So x equals 6. Bam. Now that you know that, you did the hard part. Now you can substitute 6 into either this equation or this equation. It does not matter which one you choose because when x equals 6, these two equations are equal to each other. So you can substitute it into either one and you'll get the same answer. So I'm going to do g of x because, fractions. So substitute 6 in for x, so I have b of 6 equals 2, substitute it in, times 6, minus 7, b of 6 equals, and 2 times 6 is 12, and then minus 7. 12 minus 7 is 5. Okay, so y equals 5. So your intersection point would be your x value, which is 6, and then your y value, which is 5. So if I were to graph these two equations, these two lines, they would intersect at this point. Okay. Watch your signs. I covered up number 4 a little bit. Whatever. Well, watch your signs. They throw some negatives at you, so just be careful with your signs. Moving right along. All right, so we did this in class, not this one, but we did similar things in class. So use the graph of each function provided to find the indicated values. All right, so f of 4 is equal to what? What are they telling us? They are telling us that x is equal to 4. See how they've substituted 4 in for the x? There's the x. and they put a 4 in there. There's the x, they put a 4 in there. Okay? So they're saying x equals 4, what's the y value? So I don't know, let's go. Over at x equals 4, which is right here, 1, 2, 3, 4, and y is 1. Boom. Okay. Then f of negative 4, so same idea. You're going to substitute negative, our x value is negative 4. Our x value is negative 4. Okay, negative 4. What's our y value? Uh-oh, the graph doesn't quite reach there. They didn't draw it far enough. But this graph is extending further in this direction, so it is going to hit x where x is negative 4. It will hit over here. We just don't know where. Okay, 1 second. Sorry. Okay. Sorry, distractions. So there are a couple ways you have to figure out the slope. Whether you figure out the slope by looking at the graph, because let's see, we have a point, so we have a point here, 4, 1, right? X equals 4, y equals 1. So there's 1 point. 4, comma 1. The other point that we have 0, 4. 0, comma 4. Okay. So those are my 2 points on the graph. So now that I know those, I can figure out the slope mathematically, or I can figure it out by counting. So from, here we go. I'm at 0, 4. How do I get down here? Well, let's see. I go 1, 2, 3, 3 down, 1, 2, 3, 4, 4 over. So my slope is going to be negative 3 over 4. You can figure out that that's basically like drawing a slope triangle, right? You draw a line here and a line there. Your change in y would be 3, negative 3. Your change in x would be 4. So there we go. Or you can look at your points. You go change in y over the change in x. So the change in y, my first y point is at 4. And then I go to 1. I go from 4. And I go to 1. So that's 3, negative 3, because I'm going down. I went down from 4 to 1. And then over change in x, 0 to 4 is 4. Plus my slope equals m. Is the slope. Okay. So now, following that pattern, you could figure out your next point. Okay, so I'm at 0, 4, and, well, now I'm going this way, so I would do the opposite thing. So I would go up 3, 1, 2, 3, that'd put me at 7, and I would go over 4. 1, 2, 3, 4. Oh, that would be right there. So that would be, when x is negative 4, y would be 7. So you can do it just by following your pattern. So I went up 3, which put me at 7, which is not on the graph, and then I went over 4, which put me at negative 4. Or you can write your whole equation, which is good practice. Y equals mx plus b. Substitute it in. Y equals, my slope is negative 3/4 x. Oh, I didn't put my negative. Negative 3/4 x. And what's my y-intercept? That's b. What's my y-intercept? It's 4. Plus 4. Okay. And then, it's been such a long process, what are we even solving for? When x is negative 4, what is y? When x is negative 4, what is y? So I'm just going to substitute in negative 4 for x. Equals negative 3/4 times negative 4. And then we write the plus 4. Oh, plus 4. Y equals negative 3/4 times negative 4 is just positive 3, because the negatives cancel each other out, right? A negative times a negative is a positive, so then you have 3 plus 4, which is 7. Bam! More work than I intended that to be, but it's okay. And then they tell you f of x is equal to 4. So they're telling us, remember, you can always substitute y in for f of x. So f of x is equal to 4, which means y is equal to 4. What is x? Okay, when y is 4, x is 0. We just figured that out. When y is 4, x is 0. Oh, this is very silly. We just figure out this one on your own. No, I'll do it. But it's very silly that they ask you. This is very repetitive. Okay, so then when f of x is equal to 7, what is x? When y equals 7, what is x? We just figured that out. When y was 7, x was negative 4. It was a very repetitive problem. I don't love it. All right. Let me see if there's anything weird on this one. Let me look for a second. So you're going to find g of negative 1. No, that's good. G of negative 3. Hopefully it's... Hold on. I'm trying to decide if I need to do this all for you. I close the answers. Hold on. Oh my goodness. Oh no, this is here. This is where we are. And y equals negative 4. Okay, yeah, that one's fine. Negative. That one's 5. Okay. This one's similar to, what did we just do? To what we had to do for B, because it's not quite on your graph, so you have to figure it out. But same way we figured this one out. Okay. Moving right along. You'll be good there. Okay, this one. I wanted to go over which one. It was D. Yes, it was D. Okay, so you're given d of x, which is this discontinuous graph, right? Hold on, I'm making sure this is all. Yeah, okay. So the only one that's weird on this one is D. D of x equals 0. So that means your y value is 0. Y equals 0. What is x? It is more than one value. When y equals 0, x is negative 6. It's wherever it's on the x-axis. 0, 1. And so you're just looking on the x-axis. Y is 0 at negative 6, at 0, at 1, and at 5. Yeah. So that one's just a little bit weird. So it's 0 at more than one spot. Okay. Oh, I forgot about these. All right. This one, you're just analyzing. Hold on. Can I get this to close? No? No? Okay. I should be able to get this closed, right? Oh, where it says close, maybe. That would... Oh, no. Now I got rid of everything. Fine. So, Fran collected data on the number of feet she could walk each second and wrote the following rule to model her walking rate. So she walks 4 feet times time. So 4 feet every second. What is Fran looking for if she writes D of 12? So they want you to analyze it. What does this mean? D of 12. Okay, well, they're substituting 12 in for T. Okay, so they're looking, you don't have to solve it, you just say they are looking for how far she walks in 12 seconds. Right. They're substituting 12 in for T, and T is seconds. So distance is D. So how far does she walk in 12 seconds? How far does she walk in 12 seconds? We don't need to figure it out, but we can. You would just substitute 12 in for T. So it'd be 4 times 12, which is 48. But you don't need to do that. In this situation, what does dt equals 100 tell you? That's a terrible way to phrase that question. Okay, so d of t is equal to 100. That means she walked 100 feet, but we do not know how long it took. You can figure it out. D of t equals 100, so you'd substitute 100 in for d of t. So you would substitute 100 in here. So it'd be 100, 100 equals 4t, just write the equation. And then you want to get t by itself, so you would divide both sides by 4. 100 divided by 4 is 25 equals t. So she walked 100 feet in 25 seconds. A weird thing for her to be keeping track of. Yeah. Okay. These are weird. We'll do these together. Which means I'll probably also do them tomorrow in class. It's fine. Mr. Moltbank has developed, it's a terrible name. Mr. Moltbank has developed a population growth model for the rodents in the field by his house. He believes that starting each spring, the population can be modeled based on the number of weeks with the function P of t equals 8 times 2 to the t. That's important. This is no longer linear. They threw an exponential equation at you. This is an exponential equation. How do you know? There's a variable in the exponent. See that t that's in the exponent area? Means it's an exponential equation. Okay. I feel like this should... No? Okay. They should put like A, B, and C next to these, but they didn't. All right. So the first one is find P of t equals 128. So P of t is equal to 128. So you're not substituting in for t. You're substituting in for P of t. All right. So that's going to be 128 equals, which your equation is 8 times 2. This. Oh, that's not what I want. I'm hoping there was a way to do an exponent on here, because there has to be. But kill me, please. Thank you. Raised to the t power. Sorry. I don't know how to do an exponent on here. I keep saying I'll figure it out, and I just don't think I'm ever going to. No. Okay. So I just substituted in 128 for P of t. And now, that's kind of hard to do. Now I have to solve this equation. So the first thing, oh, we should have done this in class. We haven't done this yet. Okay, so I have 8 times 2 to the t power. I want to get this by itself. I can't even highlight. I want to get 2 to the t power by itself. So I'm going to divide both sides by 8. Because this is 8 times 2 to the t, so I'm going to divide both sides by 8. I can do that. That's legal. 128 divided by 8. It doesn't tell me. Hold on. 128 divided by 8 is 16. Equals 8 divided by 8 is 1. So on this side, I just have 2 raised to the t. Okay. So basically, 2 times itself, how many times gives you 16? Well, I don't know. 2 times 2 is 4. That's twice. Times 2 is 8. Times 2 again is 16. So that's 4. I did that weird. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So t equals 4. I'm sure I'm going to be doing that one tomorrow in class. Okay, P of 4. This one's easier. You just substitute 4 in for t. So you have P of 4, and that's going to be equal to, I'm just substituting 4 in for t, 8 times 2 to the 4th power. Okay. Do your exponent first. Do your exponent first. Do you remember PEMDAS? PEMDAS? Like parentheses, exponents, multiplication, division, addition, subtraction. Order of operation. You do your exponent before you multiply. So 2 to the 4th power, we just figured that out. That's, we just did this. Oh, it's fine. 2 to the 4th power is 16. times 8 is 128. We just did the opposite of that. That's fine. Okay, and then P of 10, you would substitute 10 in for T. So same idea. Find the number of weeks it will take for the population to be over 2,000. So you're not going to get an exact answer for this. So what you do, I want to know when the population will be over 20,000. I'm going to sorry, phone call, but I think it was spam. So I'm going to have 20,000, and it's going to be equal to, I'm substituting in 20,000 for P of T. Then just rewrite the equation, 8 times 2 raised to the T. All right, and we're going to solve this for T, just like we did with this one. So once again, I'm going to divide by 8, 20,000 divided by 8. Divided by 8. It's 2,500. 2,500. 8 divided by 8 is just 1, so I'm left with 2 raised to the T. That's awful. 2 times itself, how many times gives you 2,500? Okay, let's see if I can just do this without a calculator. Ready? 2 times 2 is 4. Times 2 is 8. Times 2, here I'll write them down. This is fun for me. So I have 2. I don't have a multiplication sign. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. Times 2 is 128. Shoot, I have to check that. 64 times 2. Haha! Is 128. And then times 2 is 256. Okay. And then 256 times 2, 600, and I don't know. 500. Ooh, failed. 512 times 2 again is 1,024. Yeah. And then, what are we trying to get to? And then times 2 again is 2,048. Oh, we're close. Oh, sort of. Oh, yeah. And then times 2 again is 4,072. 4,096. I'm losing it. Okay. Wow. Sorry. That was fun for me. Probably not for you. So how many times did we do it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14? When was it? When did we hit 25,000? Let me see. Okay, so our last one we got up to 4,096. So that's too high. So then we divide that by 2, and we get 2048. So it's somewhere between, that's not the right answer. They got between 11 and 12 weeks. I got between 13 and 14 weeks. Hold on, I'm just going to do it on a calculator. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256, times 2 is 512, times 2 is 1,024, times another 2 is 2,048. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I just must have written down too many 2's. Times 2. Okay. So 2 I just did it, yeah, multiply 2 by itself on a calculator. So 2 raised to the 11th power was 2048. This is a terrible problem to give you, because we haven't learned how to actually solve these yet. Okay, so that's not, we were looking for, it has to hit 25,000. And so that's not quite there. 2 raised to the 12th power was, nope, 4,006. Okay, so that's way above. Whew! So it will take somewhere between 11 and 12 weeks for it to be over 20,000. I should just not make you do this one, but it's too late. It will be over 20,000. Oh, forgot my comma. 20,000 between 11 and 12 weeks. This is week 11. It's not quite there, but week 12, it's way over. So it will be over 20,000 between 11 and 12 weeks. Okay, in a year, ooh, I don't know why I have a text box there. In a year with 16 weeks of summer, how many rodents would he expect by the end of the summer using, okay. All right, this one they're telling us, okay, 16 weeks. So weeks is T. So this one we're just going to substitute 16 in. So P of 16 equals 8 times 2. Substitute in 16 to the 16th power. All right, so then 2 to the 16th power is, I guess we're almost there, hold on. That's to the 12th power, 13, 14, 15, 16. So 2 to the 16th power is 65,536. And then we're going to multiply that by 8. Yep, good. And that is P of 16 equals 524,288. 524,288 rodents. That was an ordeal. I'm glad we went through this together. I feel very supported by all of you. Sorry. Okay. And that's it for homework. Whew. Let me go back to my internet so I can pause. How long is this video? Is it way too long?